Greetings to viewers. Congratulations on realizing that our content exists. Thanks for tuning into another one of our meteorology segments. First thing we're looking at here are the jet streams of the eastern world. Quite chaotic in the northern hemisphere. Doubled up, tripled up, crazy eddies. The jet stream is insane. Leave a comment if you know who Crazy Eddie was. Yes, Crazy Eddie. Probably only familiar with East Coasters of a certain age group. Anyway, the jet stream's blowing backwards over the western Pacific and the northern Indian Ocean. You can see it's blowing east to west, the opposite direction of what we'd call normal. Next, surface winds. Powerful system here south of Japan. And a couple more significant rotations here farther east in the Pacific. Here are the surface winds of the western world. And this hurricane here, Hurricane Sam, is quite well organized at the moment. We won't worry about it too much. It's still east of the Caribbean. Here are the jet streams of the western world. And we see this extreme meridional jet stream flow once again over places like the central Atlantic and indeed the eastern U.S. Some cold air being injected once again into the mid-Atlantic states. Summer is over, and it's certainly cool enough to convince us here in Pennsylvania that it indeed is. So let's talk about sprites and ultra-high altitude lightning. Here's some from Puerto Rico. Just spectacular. And this is why we regularly tell you on the meteorology segments to go photograph cloud tops. If you're like 60, 80 kilometers away from a major thunderstorm and you've got clear skies, you may be able to photograph a thing like this. And it may not be particularly visible to the naked eye, folks. So yeah, check it out. This is the astronomy picture of the day. Normally it would be in our cosmology segment. But these gigantic thunderstorm jets, which are at like 70 kilometers of altitude, up in the, like the D layer of the ionosphere. This is why we tell you to photograph cloud tops. There's a great article in phys.org about ice ages. I don't know if you're aware of what an ice age is. An ice age is when Earth has ice sheets, polar ice at both poles that remains throughout the summer for the respective hemisphere. Earth has been primarily in an ice age. In fact, it has been in an ice age period for the last 34 million years, which is when Antarctica's ice sheets began to form. By the way, at that point, the planet was 3 degrees Celsius warmer than it is today. It was also much warmer during the Minoan warm period, during the Viking warm period, and during the medieval warm period. But if you'd like to read that article, it's on phys.org in the Charticle-filled Earth section. Climate Explained. What is an ice age and how often do they happen? And for the last 34 million years, they happen most of the time, and all of human civilization and history has been packed into the latest interglacial period. Here is your weather.gov map, and we're showing some freeze warnings in Idaho, southern Oregon, northern California. And apparently that part of the country is so hot that it's cold also. It's only September 29th. Here's your NASA GOES lightning map, where we've seen some quite extreme lightning here across Texas. Let's see if that's subsiding. It looks like it's moving toward Louisiana. And before we do that, let's just check the life of the stream here. And everything looks just fine here at the Smash News Network. Least busted. Name of news. So here's a real-time lightning map from lightningmaps.org. We've got some lightning here in places like Utah. But the most activity here is near Houston, also north of San Antonio and northeast of Corpus Christi. Hey, San Antonio, get out and take a photograph of those cloud tops. It might be a little bit too close for you to get a good view of that, but if you're able to get photographs of any place around those areas, such as Austin, perhaps, you might be able to photograph some sprites, and don't assume that they're not there because you can't see them with the naked eye. your camera may pick up wavelengths not visible to human vision. Anyway, that's your real-time lightning map. Quite a bit of activity there around North America. Next, we're going to windy.com to take a look at pressure. Just give that a minute to load. Again, we are streaming live here, folks. This video was originally streamed to twitch.tv/smAsho. And once again, thanks to our new followers over there. It's very wise to install the Twitch app. It's quite good. Anyway, there's where pressure cells are. Western Canada dominated by low pressure. And we'll advance this into the European forecast. There's the European forecast for pressure at 1300. That's 1 p.m. Eastern Daylight Time tomorrow. And let's continue on. Here's your simple water vapor map. Global view of the Americas. It's from the GOES 16. And we hope that helps. Shout out to our South American viewers such as Bruce Minas. And we've got to press refresh here, folks. We've got the Pacific Ocean and the cloud layer over it. It's too dark to see it with the visible satellite. So let's use the shortwave radiation map. So there's a close-up for you over the Pacific Ocean. 3.9 nanometer shortwave radiation. Quite equatorial-oriented bands of clouds there. Continuing on. And just give it a minute to load here, folks. This is the radar.weather.gov map. And the most strong storms here are near Houston, Texas. Quite a powerful system there. And a stagnant system here in the Gulf of Alaska, just hanging out. Also some showers here stretching all the way from Las Vegas to North Dakota. Seattle seeing some moisture moving out of the mid-Atlantic states. And once again, just let me refresh these maps, folks. They timed out. So here's what's going on in the cloud layer. And these systems are just kind of stagnating once again. It's because of jet stream influence, most likely. And this dry mass of air right here is acting like a high-pressure barrier, preventing the easterly motion of this. So it's going to be forcing it to the south, it looks like. But certainly causing a little bit of stagnation there as a result of this barrier of dry mass of air. So here's your recap. There's the radar.gov. I'm sorry, it's radar.weather.gov. Here's the shortwave radiation map. And there is the water vapor map. Hopefully that gives you some insight. Once again, thanks for tuning in to the channel. Congratulations on realizing we exist. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted. Name it news.